Hey there, chemistry enthusiasts. Welcome to ChemGenie. Today, we're gonna unlocking the secrets of entropy change determination. And let's dive in. So, what is entropy? Entropy, denoted by S, measures disorder or randomness. This thermodynamic property is also a measure of how much energy is unavailable for conversion into work. Think of orderly arranged blocks of woods, which means low entropy, and a disorderly arranged blocks of woods, which means high entropy. Entropy increases as energy becomes less organized. Entropy changes delta S determines a reaction spontaneity. A positive delta S greater than 0 indicates increased disorder, favoring spontaneity, while a negative delta S less than 0 indicates increased order, disfavoring spontaneity. This principle explains why some endothermic reactions occur spontaneously, demonstrating that spontaneity isn't solely driven by energy decrease, but also by the tendency towards greater disorder or statistical probability. And there are three factors affecting entropy. The first one is change in phase. Entropy increases as substances transition from solid to liquid to gas. Solids have low entropy with confined particles and minimal movement. Liquids have moderate entropy with slightly separated particles and limited movement. Gases exhibit high entropy, characterized by widely spaced particles and free movement. Conversely, transitioning from gas to liquid to solid decreases entropy, yielding more order arrangements. And the second one is change in temperature. Increasing temperature heightens molecular motion, leading to greater disorder and increased entropy. As temperature rises, solid particles vibrate more energetically, while liquid and gas particles move rapidly. Conversely, decreased temperature reduced molecular motion, resulting in lowered entropy and increased order. And the last factor of affecting entropy is number of particles. The phrase "the more the merrier" can certainly be applied to entropy. It is definitely merrier when there are more people in gathering. When a lot of people are present, there will be more movement, more noise, more waste, and definitely greater disorder. This means greater entropy.
Consider a chemical system represented by the following equation. A sub 2b is a product of 2a plus b. Entropy increases when the number of particles rises or disorder grows. For instance, in the reaction A sub 2b, product of 2a plus b, entropy increases because 3 particles replace 1. Generally, entropy rises with more particles. Let's try the sample exercise. Predict whether the entropy increases or decreases. Sodium ion with a positive charge in aqueous solution plus chlorine ion with a negative charge in aqueous solution yields sodium chlorine in solid form. When ions transition from an aqueous solution to a crystalline solid, entropy decreases and delta S is less than 0, as the ions move from a highly disordered state to a more orderly state. Entropy change determination. A numerical value for entropy can possibly be determined for any substance under a given set of conditions. Entropy change can be measured by a calorimeter, the same instrument used in determining enthalpy change. The change in entropy is related to the heat transferred during the process. For processes occurring at constant temperature and pressure, the change in entropy can be calculated using the following equation. Delta S equals Q over T. Whereas delta S is change in entropy in joules per Kelvin. It is negative if heat is released by the system and positive if heat is absorbed by the system. Q is the heat transferred at a particular temperature in joules. T is the temperature in Kelvin or K. However, this equation applies only to processes that are almost reversible. A typical example is the melting and freezing process and other phase changes. So let's solve a sample problem. Calculate the entropy change. Delta S vaporization when 1 mole water in liquid state is converted to 1 mole steam at 1 atm pressure. So the given is Q equals 40.7 kilojoules per mole and the temperature is 100 degrees Celsius or 373 Kelvin. We need to change kilojoules to joules and substitute the given values in the following equation. So here's the solution. Entropy change vaporization equals enthalpy change vaporization over temperature. Entropy change vaporization equals 1 mole times 40.7 kilojoules per mole, 1000 joules per kilojoules over 373 Kelvin. And don't forget to cancel the same unit. So the answer is entropy change vaporization equals positive 109 joules per Kelvin. The entropy of a substance can be obtained directly from the tabulated values of standard molar entropies. And entropy change can be calculated using the equation. Standard entropy change equals the sum of the product's standard entropies multiplied by their stoichiometric coefficients minus the sum of the reactants' standard entropies multiplied by their stoichiometric coefficients. So let's solve a sample problem. Calculate the standard entropy change for the following reaction using the tabulated standard molar entropies. So here's the given. So let's substitute it to the formula. Standard entropy change equals 2 mole times 240 joules per mole to Kelvin minus 2 mole times 210.7 joules per mole to Kelvin plus 205 joules per mole to Kelvin. Standard entropy change equals 480 joules per Kelvin minus 421.4 joules per Kelvin plus 205 joules per Kelvin. Standard entropy change equals negative 146.4 joules per Kelvin. The result shows decrease in entropy of the system, which is consistent with the expected change dictated by a decrease in the number of particles.